I'm going to present you our work on our Timesheets.js project, which is basically an attempt to use most of the interesting things in SMIL in modern web development, HTML5 and CSS3. So here's a typical use case. This is what we wanted to implement. So this is a web radio archive. So you have a media player. You have some HTML content here that is synchronized with the media. Like if you advance in time, specific sections are displayed on the screen. On some sections, we have bonus elements which can be activated by the user and disactivated. We wanted also to have content-based navigation. So here you see the timeline is segmented, so we can jump from one section to another, either sequentially or directly using a table of content. So this is a rather typical multimedia document. But, oops, sorry. We could have been doing it with pure SMIL, relying on a real player or ambulance plugin. We could have been doing it with Flash, but we didn't want to rely on plugins, mostly because we wanted to benefit from modern browsers' native rendering. We also wanted these applications to be supported by mobile devices. We even wanted to have one single document to be displayed on both desktop devices, laptops, and mobile devices, smartphones, tablets. And we still wanted to have a declarative description of these files to ease the authoring workflow. So this is how we did it. We wanted to keep the declarative aspect of SMIL, but reusing HTML and CSS as much as possible. So obviously, the content structure and multimedia handling, audio, video streams, are perfectly handled with an HTML5 file. The presentation, of course, is done in CSS3, which allows us to use transitions animations. And this leaves us with a question of how do we handle the time structure of the document, which is both the synchronization of the HTML content with the media stream and the handling of the user interactions. We could have been doing this in pure JavaScript, but we wanted instead to have a declarative file gathering all these time informations and to pass these informations with a single generic JavaScript library. This is what our Timesheets.js project is about. So of course, this data, we're not reinventing the wheel. So we're storing this temporal data in SMIL timing. So SMIL timing, for those of you who haven't heard of it yet, it's a declarative standard. It's a rather old standard now. It's a W3C recommendation. It's one of the 12 SMIL modules. It's probably the only SMIL module that is worth saving, if you ask. And SMIL Timesheets is, well, SMIL Timesheets is a temporal counterpart of CSS style sheets. So this allows us to take SMIL timing data and use it in a separate file, like we would do with CSS style sheets. SMIL timing and timesheets are designed to synchronize structured content. In our case, this is web content, mostly HTML and SVG. There's been a lot of work that has already been published on this subject. Our friends from the CWI there sure know a lot about that. My predecessor at INRIA have worked a lot on it too. I'm very pleased to see that Patrick Schmitz is with us today, because my colleague at INRIA has been telling me about his work for quite a few hours. but we still couldn't use all this work from scratch as is, because this work was done before the recent improvements on HTML5 and CSS3 for handling multimedia content and all the nice features of CSS transitions and animations. There's no JavaScript implementation of such timesheets. There's been one that's been done in 2006, if I remember correctly, or 2005 by Petri Vuorima in Finland. But this was, of course, way before HTML5 audio and video. So we had to write our own. So this is what our contribution is about. First, it is to design a timesheet engine. We needed to have another timing model that is both compatible with continuous media, such as multimedia streams and transitions animations. And we also needed this timing model to be event-friendly, to be event-driven when needed. We're also proposing a few extensions to the current spec to be able to benefit from the new cool stuff in HTML and CSS3. And we're also trying to propose this timesheets.js not only as a parser and an interpreter of SMIL timing data, but also as an extensible framework in order to build generic components for multimedia documents and to expose an API and events so applications can be built on top of this time model. So here's a very basic example that is used in our demo. This is how HTML content can be synced with an audio stream. So as you can see here, this is pure SMIL timesheets markup. For every item, we have a select attribute, which is a target, a CSS selector target. So we're getting here the element that has the ID section 1. And we're telling it to start at the very beginning of the media stream. Since we're in a next called time container for those SMIL semantic, the second item will start at 1 minute and 12 seconds. And when it starts, it will hide the first item, and so on until the media stream is over. So this allows us to keep the HTML content in sync with the audio track, but it also allows us to use temporal navigation. Like in this link here, if I'm asking to display section 3, it will jump to the third section. So this allows to give temporal links. Well, this ensures that spatial links also have are handled on the time dimension. These begin end attributes may contain non-numerical values. This is what we call even values. So people who design SVG animations should be aware of that. It's element ID dot DOM event type. So this is what we use here to display our bonus sections. When we click on this button, we display the bonus. When we click here, we hide it. So this is what is described here. The bonus of the second section starts when we click on the button that has the ID open to, and it ends when we click on the button that has the ID close to. As we also wanted this bonus to be hidden when we jump to another section, we're adding this, section 2.end. This is an interesting case, simple, but every time that an HTML element is activated or disactivated by SMIL, it fires a begin and end event, respectively. So this can be used in your own JavaScript So you can set event listeners and start your own bunch of code when this or that element begins or ends. But you can also use these events in a time structure, in a timesheet, to synchronize another time tree with the activation or disactivation of any element. As mentioned a bit earlier, we wanted this library to be extensible. We have multimedia documents. We want them to be hackable like any other HTML plus whatever documents. So we have these begin end events that can be listened to. You also can set on begin on end attributes, which is completely equivalent. We also expose an HTML media element API. So this API is the one that you have to control audio and video tracks. So it's rather well known now by most web developers. And we found that it was relevant to expose a significant part of this API to our time containers, because our time containers, even if they're event-driven, can be seen as a media player, at least at some point. On this HTML media element-like API, you can build a set of user interface components that can benefit from this time informations and from this SMIL way to activate and deactivate HTML elements. This is, for instance, the case of this timeline here. The timeline itself, the segments here, are created and positioned according to the temporal data that is being gathered from the main time container. This button, first to get to the first section, to get to the next section, and the last one, are also using SMIL stuff to control the media. And even the table of content here, the way that it works, that it interacts with the document, is relying on SMIL stuff. Yeah, and we also, in our library, we provide a parser, which is very flexible, so you can even decide to add your own custom attributes to your timesheets. This can be useful if you want to address a very specific need that is not generic enough to be part of the specification. But it's also very useful if you want to test a new attribute that you would like to submit to the spec. So it's a good way to test non-standard behaviors or non-standard features on a well-known SMIL basis. So I would like to thank Rodrigo for giving me the conclusion of this presentation. Yesterday, this was his conclusion at yesterday's HTML5 multimedia workshop. There's a huge value in the flexibility and readability of a higher level timing and synchronization model. There are model alternatives to SMIL. Rodrigo is working with popcorn.js for an example. There are possibly other time model. This is how I think that the key benefits are using SMIL timesheets. The first and most important one for me, it's a bit old school now, but separating the content, the presentation, and the timing still makes sense for a lot of users. The content in HTML, presentation in CSS, and the timing in SMIL allow to cleanly separate the tasks. You can reuse some HTML content, give the presentation task to a web designer, and leave an author play with SMIL to write a scenario. Compared to Flash or pure SMIL solution, the fact that we're using the browser's native rendering is a significant plus. We're relying on a very lightweight JavaScript library. I think it's a little under 8 kilobytes at the moment. It's completely cross-browser. There's no jQuery or whatever dependency to an existing JavaScript framework, though it's compatible with most JavaScript frameworks. It works on all browsers, including mobile device, even including IE6, because we're using a few fallbacks when necessary. So a single file can be served to almost any browser, from IE6 to the Android stock browser, going with Opera, Firefox, Chrome, whatever. It should work in all cases. If not, please ping me. It's a stable syntax. When designing your own data format, choosing the syntax is not an easy task. Especially if you want to interoperate with other people who are providing content for your application. So relying on a W3C recommendation, even if it's not built in browsers, does make sense in this purpose. There are still a lot of users who are still quite familiar with SMIL, who can reuse their skills using this library, and they could not spend enough time to be proficient with JavaScript to implement a similar behavior on their multimedia documents. So this is why a declarative management of all these user interactions, all the time synchronization with the HTML content and the media can make sense. The other point of having a declarative syntax for that is that it paves the way for authoring and validation tools. You can consider at some point that the implementation is tested and that it's testable, and then you can have your own tools to validate, to be sure there's no inconsistency in your scenarios that is described in SMIL. As I mentioned, it's usable by non-developers. I suggest if you have some time to try this URL. Those guys have been doing like 20 or 30 or maybe more SMIL-based slideshows, reusing old PDF slideshows and synchronizing them with either video or audio tracks. And it's extensible by web developers. If you want to build an application, a multimedia-based application, you can put most of the temporal behavior in a SMIL file and build your application on top of that. This is what I'm trying to represent with this little schema. This is the typical web-based approach: content in HTML5, presentation in CSS3, and a good bunch of JavaScript to synchronize everything with the multimedia tracks, handle the user interactions. And this is what we're proposing. It's very similar, but the difference is that we're proposing a document approach. All the scenario, all the timing, synchronization, and even handling is done in document, SMIL timing, of course, which is interpreted by JavaScript, but it's a document. And you can still use JavaScript to enhance this document to make it more interactive or to be part of a bigger, more generic app. And that's it. We have a few use cases on our website. Feel free to try this URL, and you'll see a few other use cases. This is not only dedicated to multimedia. Like this slideshow here is pure timesheet stuff. There's no specific JavaScript code. It's entirely described in timesheets. Feel free to contact us if you're interested in this technology or want to implement it for specific use. And thank you for your attention. Yes?
Hi. Is this on? It's parked. The work is very nice. We've been following it for a long time. There are some general questions, I think, that one of which I posed yesterday, but I'd like to repose today. If we look at integrating SMIL timing with HTML, using HTML as the host language, then there are two general approaches. One is, and both of these were proposed initially at about the same time. One is to have out-of-line timing in timesheets, the way you do it, and the other is to have inline timing, which is the approach that was developed by HTML plus time. Yep. As I understand it, your library allows for both, that you could have
Correct.
Both inline timing and out-of-line timing. For the applications that you've chosen, why do you think, you've stressed the out-of-line timing, why do you think, is that a better approach? If so, why do you think that's a better approach? Because that's more of the timesheets model than the time integration model that has been around for a while.
It would have been possible to do it with inline timing, but it wouldn't have been as handy. There are two things. The first thing is we wanted to be able to give the presentation task to a web designer and leave the scenario, the synchronization with the media to the real author, the content author. So this allows us to more flexibility just for the authoring workflow. But there's also a technical reason for that, which is mainly these bonus boxes. If we used inline timing, we would have had to design the DOM structure to take this timing structure into account. So we had to keep both trees somehow parallel. The special tree, the DOM tree, and the timing tree should have been consistent together. With the timesheet approach, we can think of the DOM structure completely freely and then target specific elements of this DOM structure with the timesheets, playing with these CSS selectors. So this offers more flexibility. It's not a matter of reusing the timesheet in other radio archives, because this is very specific to each archive, but it's just a matter of not having to cope with the DOM structure when thinking of the scenario, of the time scenario.
Although I would think that with native audio and video elements, by separating that structure out, you'd actually increase the maintenance burden, because people could have non-identified pieces of audio and video that may conflict, so that you're not all of the temporal control, or no, some of the temporal control is implicit as part of the DOM structure of the sort of basic HTML5 presentation, and others of it are controlled by the timesheets. Mm-hmm. Do you see that as a maintenance issue, so that it's a sort of a problem of separating out part of the timing structure from all of the timing structure? If you understand what I'm saying.
Yes. Yes. I think there is a gray area in the spec, because if I followed you, if you have both inline timing and external timing, one DOM element can be the target of several time nodes.
Right.
And when one time node says this element has to be activated, and when another one says this element has to be disactivated, what should we do? So should we consider that the last rule wins, like we do in CSS? Should we consider that it's kind of a Schrödinger box where every element can be activated or disactivated by several times trees? My personal opinion is that we should keep the CSS approach, like the last one who speaks win. And so the inline timing could be used to define exceptions to the rules that are defined in an external timesheet. That's my guess. I've tried to use the other approach, and it quickly became a nightmare.
Okay, but I guess the point I was trying to make is that some of the inline timing is implicit because you can always toss in a video tag that plays a piece of video, and if it doesn't have a class attribute or another control attribute that refers it to the JavaScript timing, to the timesheet timing, then you have an implied conflict.
The video that we have in HTML5 or SVG 1.2 is not the video that we have in SMIL. There's no implicit timing of audio and video, at least in our approach, unless you explicitly define a media sync attribute to say this time container is synced to this media, and then you're defining explicitly a time behavior to a media. But we're considering that by default, this should be the time structure of an HTML page, which means no time behavior by default.
Good. I have one question, then you can go, and the other is the support for this within the. I'm just helping you out here. Support of this approach within Mozilla. Mozilla has some proponents in their organization that take a sort of a different view. That is a more, any concept worth having is a concept worth reinventing. And, that kind of goes against the reuse issue. Is there, I know there's broad support for this within INRIA, of course, where people have been looking at this for a long time. But have you found broader support, for example, within Mozilla for this approach?
Not much. This is a discussion we had yesterday with Nathan. This is basically bringing a JavaScript implementation is like shooting oneself in the foot, because then people will ask, why would you want this to be part of the browser if you can do it in JavaScript? So there are at least two reasons to include this in a browser. The first one is that we need a more fine-grained control of the synchronization of the continuous media. Currently, the HTML5 API gives us 250 milliseconds time rate, which is way too low for lots of applications. And there's also an accessibility concern, which is very difficult to address with a pure JavaScript approach. So I'm in contact with Sylvia Pfeiffer for the accessibility at Mozilla, and other guys on the content team at Mozilla for the, the more classical content approach. Should this be part of the browser or not? And it's not taking good shape, because mostly the fact that Microsoft has abandoned HTML plus time exactly at the time that they're enabling audio and video, and at some point SVG in IE9, and now CSS transitions and animations with IE10, hasn't been well accepted by, has been a strong argument of not doing it in the browser. The other thing is that for most people, when they hear SMIL, they are thinking of SVG animation. And they're saying, why on earth would we use SMIL since we already have CSS3 animations? So there's also a work to be done to explain what can be done with timing, with SMIL timing, to having a decent editor of SMIL timing would help a lot too. And I feel guilty about that, because that was another part of my contract that I had with INRIA, and which I have some kind of a beginning of an editor, but not the kind of editor that I could put in everyone's hand. So I think there's a lot of evangelism to be done, and probably the best approach, in my opinion, would be to forget HTML5 for a moment, to focus on SVG2, because they already have audio and video tags. They already have a bit of SMIL, because they implement a significant part of the basic animation module. And most people who have tried to do SVG animation are very frustrated by the fact that they can't add any time structure to their animation. So I think we should start proposing this timing or timesheet approach to SVG, and see how it goes then with HTML5.
Okay, just one question and one comment also. As a member of the SVG working group, we can talk about SVG2, but I think we will have also big debates. But okay, the question is rather short. SMIL timing module is quite a big beast, and in particular, it has nested time containers.
Yes.
This is, I think, one of the major arguments against SMIL within the HTML5 community, that it's too big to implement. In your scenarios, have you experimented with nested time containers?
Yes, sure. Well, not in this demo.
Because I looked at the website, for example, this INS Lyon website, and most of them follow this template.
Most of these, at INS Lyon, it's a bit like that. It's 100% or almost media-driven. So it's just one big time container and begin dates to synchronize every HTML fragments with the media. But oops, maybe some Wi-Fi would help.
Okay, maybe.
But you can have on the very front page of the Timesheets website here. Well, again, you have nested time containers, and if you go to the slideshow sections, you'll see that we're nesting time containers for many use cases. But it's rather in an event-driven approach that we're nesting time containers. For instance, in this slideshow, I've implemented the slidey micro format with pure timesheet. So it's only a 20-line timesheet, which implements the whole slidey micro format. And in this timesheet, we're already nesting time containers.
Okay. I think that's the major argument for SMIL at the moment, nesting time containers, because that's what's missing in all other...
In SVG animation, true.